Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you are ready today because today, despite all the news, and there's this week has been some good and some bad. I will say that we're going to let the bad speak for itself, but I will say the good. Being able to see a new manned moon mission, a new Mario movie. Really, everything is just going great for everyone out there. So, with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, really anything that you need to know about the program, you can find at computeramerica.com, including the show notes. We'll get to those in just a little bit, but these are really important for today's show, especially because Ralph puts them together, and it's everything that he talks about, and then some, all condensed, or not condensed, but well made, well formatted into an easy to read document. So check that out, computeramerica.com. Now, with that being said, let's go ahead and just bring Ralph on. And he is our longtime contributor, and he has really, filled this role expertly, the science and tech trends correspondent. And we'll get into exactly what that means in just a moment. But Ralph, welcome back onto Computer America. How you been?
It's always great to be back. And does the world ever we desperately need some uplifting and positive news. And friends, that's what Ben and I do every Friday. If you're new to the show, welcome. And let's explain what we do. So what Ben and I do each Friday is highlight 4 articles that show us key trends and developments in all things science and technology related, including, well, of course, almost every single story almost has something to do with artificial intelligence. That's a given. But we also look at robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics, on and on. Most important of all, especially this week, we're going to give you hope for a better future thanks to the amazing breakthroughs happening every single day in the world of science and technology.
Absolutely. And I think I wanted to start the show off just a little bit real quick and talk about the Artemis 2 launch.
Yes.
And, I guess first I'll just say that, manned moon mission after, 50 years that we're finally sending people back. Obviously, everyone knows they're, slingshotting them around the moon. But yeah. Ralph, this is, obviously not just like, 6 months ago they were planning this. No, this has been years and years in the making. Pretty awesome to see, right?
Oh, absolutely. And it's still mind-blowing to me that it's been a half century since we've done this kind of thing. It just, part of me says, why didn't we have moon activities and exploration in between? It's like, what?
Probably because there's just not a lot of, who knows, maybe the moon's just not that cool. I don't know. But I will say that just from a tech point of view, I thought it'd be, kind of fun to point out, first of all, they got the toilet working again. So
yes, thank goodness.
Thank goodness for that. I can't imagine 10 days with no working toilet. But then, Ralph, also, I wanted to call attention to, for everyone out there who enjoys using Microsoft Outlook, yeah, apparently the Outlook, so they contacted Houston and they said that they had 2 instances of Outlook running. So that's not very normal for a computer. And also, let's face it, I don't know. Ralph, do you think you need email in space? I don't think you need email in space. That seems like a, in a way message to me. But they then said neither instance of Outlook was working. So,
oh no.
Yeah, that was a direct quote. So if you're Microsoft, you're probably like, maybe we should look into that. Again, the quote is from Wiseman, the mission commander, saying, "I also see that I have 2 Microsoft Outlooks and neither one of those are working," which resonates on Earth and in space, I guess. So,
which is more daunting? toilet or Outlook?
Or two outlooks, yes, as if things just couldn't get worse. But yeah, all that aside, it's going well. Looking forward to, about the time that we have another show here. Hopefully back on Earth, I think, or just about landing. Still very cool to see. And there you go. So with that being said, the show is not about Artemis 2, but we are taking it to space for story number 1. So Ralph, before we get into the stories, let's tell the nice folks what it is that we try to do here. And and then we'll go to story number 1.
You got it. Well, as I mentioned before, we cover all kinds of things in science and technology, looking at breakthroughs. And most important of all, of the 4 stories, each one is positive, uplifting. I could dredge up really scary stuff, but no, that's not good for me, not good for you. We're going to go on and do some fun stuff. The first story picked up from nationaltoday.com and many other outlets too. So this story had quite a bit of pickup. And to set the stage, what we're going to talk about in this first story is there's 2 key efforts in terms of long-range space exploration using sails, either solar propelled, if I could say that, solar propelled sails, or in this case, a new idea for photonic sails. So we'll better explain this, but let me give you the headline here. Researchers develop photonic crystal light sails for interplanetary exploration. Subhead: new design combines low mass, strong wavelength selectivity, that's particularly interesting in this story, and scalable fabrication potential. So this is geeky. This is space
you're starting
science
out light today, Ralph.
out. Yeah, this is geek out time. So I'm just warning you up front. But what I do in the show notes, folks, if you come out to computeramerica.com, get the show notes, you'll have the links, you'll have pictures. Sometimes we have links to videos, all this good stuff. But also in blue text, that signals stuff I've inserted to help augment the article or position it and so forth. And I call them side notes often, so check that out as well. But in the blue notes or blue text in the beginning of this story, I say, before we discuss this announcement, I need to highlight what NASA has in the works. They've been exploring a solar sail technology for space exploration. This article we're looking at here only compares a new technology we'll talk about from Tuskegee University in Alabama, I hope I'm saying that correct, with traditional chemical propulsion. So the article says, hey, these guys at Tuskegee University have a new idea for photonic propulsion of a space sail. And they say they only compare that to traditional chemical propulsion. Well, you needed to know that NASA has solar propulsion. Why can't I say that?
You got it.
Anyway, that's going on in parallel. So, but the university research paper does acknowledge NASA's solar sail. Their research paper does. The article doesn't. Okay, so that's the quibble I have. And cites their research as part of an effort to move away from chemical propulsion. First, here's what NASA has been up to. And you can come to the show notes and get more details about NASA's solar sail technology. I won't go through that right now, but I do have a link to NASA's program for that, and it's really a great website. Check it out if you want to come out to the show notes. So that's what's going on in terms of setting the stage here. Solar propulsion or light propulsion. We'll talk about that. So researchers from Tuskegee University in Alabama have recently demonstrated a practical light sail design that could revolutionize space travel by using lasers rather than chemical fuel. Again, they should have mentioned the solar thing in the article, but there it is. Now, one thing I didn't know, Ben, is I thought, well, okay, laser, how viable is that for a long distance? And what are the other considerations? And it's taken into account in this research from Tuskegee University. But a little side note I will read this time. Lasers can be beamed extremely far into space. Even light years? What? But only if transmitting optics are enormous. Well, that kind of makes sense. In practice, the useful propulsion range for a realistic light sail is much shorter because diffraction causes the beam to spread. That was the one that immediately came to my mind when I first heard about this idea. And that spreading, that diffraction, is a fundamental limiter, not power. So we can generate a tremendous amount of power to shoot a laser into space, but ultimately it's going to diffuse. That's where I think NASA might be on a better path with solar or starlight propulsion. So, yeah, kind of interesting setup there.
Yeah. I know that, and I was just trying to look it up while you were talking about, they wanted to create like a solar sail for, I want to say the Voyager system, because, obviously chemical stuff's going to run out far sooner than light, the ones that have actually left our solar system, like, it makes a lot of sense. And obviously, those solar winds that kind of come off the sun, all that good stuff. But Ralph, I think even then we're going to have to look into propulsion, kind of further, because once you leave a solar system, well, you kind of lose your solar winds. You kind of lose the propulsion that you get from there. So what do you do when you get between systems? And that's, I guess, what they're also trying to tackle.
Yeah. It's a big challenge, to say the least. But going back into what the folks at Tuskegee University are up to, the Photonic crystal light sail developed by Tuskegee University researchers could significantly reshape space travel by addressing the overheating and degradation issues of traditional metal-coated polymer sails. So there's a little wink and nod to the NASA side of the equation. This new design, which uses a nanoscale pattern of germanium pillars, air holes, and a polymer matrix, aims to maintain high reflectivity without the weight penalty of thicker metal coatings in, I'll call it, traditional or current sails. I told you this was geeky, folks. Okay. So quick side note, germanium pillars are nanoscale or microscale vertical structures made of germanium. They are engineered as part of photonic, electronic, or mechanical devices. They're typically fabricated as tiny upright posts that manipulate light, strain, or electrical behavior in advanced material systems. Oh, sure.
Yeah.
Everybody knows that.
The words all individually make sense, but then you put them together and it's hard. But yeah, the notes are in the show notes, folks.
Yes. And now we're going to geek out even more. Get ready. The structure's photonic band gap, this is actually really interesting, is tuned to match the propulsion laser wavelength, allowing for continuous thrust generation and potentially accelerating the sail to speeds of several hundred meters per second within 1 hour under idealized conditions. Okay, side note, what the heck is a photonic band gap? It's the range of optical frequencies or wavelengths that cannot propagate through a specific material. Think of it as a no entry sign for certain colors of light. So what the folks at Tuskegee University did is they created a sail that when the laser hits it, it's only going to respond to the particular wavelength of the particular laser that's being used to propel this sail. Okay, you get the picture there? It's a little geeky, to say the least. And to wrap it up, this advancement could lead to more efficient and sustainable interplanetary space travel, reducing the reliance on onboard propellant and increasing the potential for long-duration, high-speed missions. But again, this is in parallel with the solar sail technology NASA is looking at as well. So we'll see what wins out. I think probably this laser technology might be for shorter distance kinds of applications. We'll see.
Yeah, it's once again just going to be a little bit of everything that might make this work. And, even if this isn't for, obviously with Artemis 2 on mind, crewed missions, Ralph, maybe for satellites that we're sending to further reaches and, smaller things that we can propel much faster, makes a lot of sense because, there's talk of, I want to say like nuclear generators and nuclear reactors on these things. But yeah, it's, I think everything at this point needs to be explored. And, Ralph, it's sometimes we talk about space and people might get the idea that what happens in space doesn't really affect us here. But no, this kind of research really, in a lot of cases has real application for, everyday people. So
absolutely
something awesome might come from this. Maybe laser propelled cars. Who knows? So, we'll see. Story number 2. Let's go ahead and skip on down. And this is a story about, batteries. And, everyone wants the newest thing. Everyone, whenever I talk to people, it's like, why doesn't my phone last a week? It still only lasts, 24 hours, which, by the way, phone batteries getting a lot better lately, but still,
Yes.
why does my phone still only last 24 hours? Why does my watch only last, 12 hours or something like that?
Mm-hmm.
And, Ralph, we look to the future for batteries, but story number 2 is looking to the past for batteries.
Yes. Yes, this is such a fun story. It comes out of the University of California, Los Angeles, their news outlet. Headline, How UCLA Scientists Help Reimagine a Forgotten Battery Design from Thomas Edison. Wow. So we have a link to the story, of course, and to their research paper. It's really very cool. And Ben, you had talked about this, I don't know how many shows ago, the bit about a little known fact: in the year 1900, electric cars outnumbered gas-powered ones on the American road.
Mm-hmm.
And I think for a lot of us, including me, and when I first learned about this, I said, what? Anyway, the lead-acid auto battery of the time, again, we're talking about 1900, courtesy of Thomas Edison, was expensive and had a range of only 30 miles. Seeking to improve this, Edison believed the nickel-iron battery technology was the future, with the promise of a 100-mile range, a long life, and a recharge time of 7 hours, which was fast for that era. I'll take 7 hours today because I have a slow charger in my garage.
Really, that sentence just really shows how much things change and how much they stay the same, obviously. Where Thomas Edison is like, this new battery, triple the lifespan, or triple the distance.
Range, yeah.
Thank you. Triple the range, double the lifespan, and even faster charging times.
Yes.
And it's like every time we hear about a new battery technology, they're still trying to do that time and time again. So
yeah, exactly. I mean, in the world of batteries, of course, lithium ion naturally, but then there's the sodium battery research and this and that and so on and so forth. All kinds of battery, aqueous batteries that are water-based, on and on. But nickel-iron battery, okay, what's that all about? But going on into the story here, but that promise of Edison's next generation of nickel-iron battery, the one that could do a 100-mile range and be charged in 7 hours, it never really reached reality. Early electric car batteries still suffered from serious limitations, no surprise, and advances in the internal combustion engine won the day. So that's what happened. It wasn't that people rejected electric cars back then, it's just that the internal combustion engine, before we knew about pollution and all the other problems, just sort of took over and won the day. So now, here's the news. An international research collaboration co-led by the University of California, Los Angeles, has taken a page from Edison's book, Developing Nickel-Iron Battery Technology that may be well suited for storing energy generated at solar farms. So they're not talking about this being a competing technology for automobiles, but something that could be good for in situ, in place, large battery storage for solar farms. Big operations, right? Now, going on, the prototype battery was able to recharge in only seconds. What? A nickel-iron battery based on Edison's ideas, of course refined, but can recharge in only seconds instead of hours, and achieved over 12,000 cycles of draining and recharging, the equivalent of more than 30 years of daily recharges. Wow, you can see why this could be so great for a solar farm. And so on. Yeah.
And just to give a little excitement to solar, they're finding, Ralph, that I actually just learned about this the other month, was when it comes to solar panels, they're still not exactly sure how long solar panels kind of last, because I think, traditionally, Ralph, when you bought a solar panel, they said, the lifespan of solar panel is about 15 years. Over the years, they've bumped that up to 20. And I think now they're looking at maybe even bumping, the ones that you installed 20 years ago might actually last 25 to 30 years. So to have a battery that could last as long as the solar panel itself, that just makes the system all the more, I guess, kind of resilient. And
that's a good point. That's a really good point. And again, I'm fascinated that the researchers themselves say, not for cars, but for applications like supporting a solar farm. So So the technology here, we're going to geek out a little bit. The technology was built from tiny clusters of metal patterned using proteins that were then bonded to a two-dimensional material made of sheets only 1 atom thick. Huh. Now, a little side note from me, the article does not name any specific proteins. It only describes them functionally in their research paper as proteins that act as scaffolds for mineral growth, similar to those used in bone formation or shell formation. Very geeky stuff here, folks. I don't profess to understand it. But to wrap it up, despite the innovative ingredients, the techniques are deceptively straightforward and inexpensive. That's so key in this technology research.
For sure. And also, as always, Ralph links to the articles and research papers themselves if you really want to get into the gritty of it, the nitty gritty of it. But I will say that just a quick glance in the study, the team used proteins that are byproducts of beef production. So what does that mean? Yeah, there's a lot of different kinds of protein and a lot of different beef production. So who knows? But
but that's pretty interesting in its own right.
maybe trying to take something that would otherwise be waste and turning it into something useful. So who knows?
Well, I'll tell you what, Ben. I'll bet you that artificial intelligence played a role in these guys saying, hey, we need a protein to do this. Go out there, AI, and tell me which proteins would, it's a beef protein, X, Y, and Z.
Maybe they needed to burn through a grant that they got. And they said, what protein can we use? And they said, T-bone. We need T-bones. That's the protein we need. And they just bought tons and tons of T-bones. That's what I'm betting.
That's funny, man.
Who knows? Okay, story number 2. No, it's really cool, and I hope that and if nothing else, Ralph, it's because Thomas Edison kind of got his name dragged through the mud lately. Between Tesla and Edison, there's this whole kind of who's the good guy, who's the bad guy kind of thing. But still, it's still science history and American history, and it's still worth kind of going back and not just looking at it and cataloging it, but trying what they were doing back then, and it's really cool.
Yes.
Very, very cool. So story number 2, ladies and gentlemen, you can find that there. Story number 3, we're going to go ahead and, we've been going really heavy, laser space travel, crazy new batteries. We're going to go light. And Ralph, story number 3, we're going to look at, whenever you need to measure something, you pull out a tape measure and you get, within a centimeter. Pretty good. But story number 3 promises to get a little more accurate than that.
Yes, it does. And this continues on with, I think I'll call today's show the Geekathon, because this is also very geeky stuff. Comes from phys.org, short for physics.org. Headline, Quantum-Inspired Laser System delivers distance measurements with sub-millimeter accuracy. And it comes from the University of Bristol, of course, in the UK. Let's get into this. Researchers at the University of Bristol have demonstrated a quantum-inspired laser system. Key here is quantum-inspired. We'll explain. A quantum-inspired laser system capable of measuring distances within sub-millimeter accuracy, even under strong sunlight. And you'll understand in a moment why that's so important. Now, the key challenge is solving the sunlight and atmospheric noise problem when you're doing a laser-based measurement system. Okay, think of those surveyors you might see out on the tripods, and they've got the little laser things trying to create point clouds to define a zone for maybe building a road or whatever the case may be. So that's sort of what we're talking about here. So a problem is sunlight and atmospheric noise. So sunlight and atmospheric noise are major obstacles for, in this case, long distance optical laser-based sensing. That's what we're talking about here with this research. The new quantum-inspired laser system method suppresses background noise while keeping the signal strong, enabling high precision measurements outdoors. Wow.
Who knew all you needed was just a little bit of quantum science to really get around that whole light thing and atmosphere thing?
Well, get ready. We're really going to go down the geek rabbit hole here. So what they're talking about is quantum ideas combined with classical hardware. And let's explain. The technique borrows from a quantum effect, excuse me, a quantum effect called energy time entanglement. Oh, sure. I deal with that every day in my brain. Energy time entanglement. But instead of using true quantum light, what? The team recreated its noise resistant properties using a classical laser. So they took a classical laser but applied ideas and realities from quantum entanglement, energy time entanglement, and true quantum light, but still used a classical laser. I know this is mind melting. This makes the system more practical and easier to deploy in real world environments. Now, I am going to go through a couple of my blue text side notes because I went, what? Energy time entanglement? True quantum light? What the heck? So, first, energy time entanglement is a form of quantum entanglement where two particles, usually photons, are linked such that their energies and their times they are created or detected are correlated in a way that cannot be explained classically. Boy, does that describe quantum mechanics. I mean, it's so weird. It's one of the most robust and practical types of entanglement used in quantum communication. Oh, sure. Absolutely.
So, yeah, the last time that I think we covered quantum entanglement here on the program was when they were talking about using it to communicate over vast distances, because they found that, no matter how far away these two got, once they were entangled, they responded the exact same. So, if, and right now, Ralph, like, is only one quantum particle, and you can't really send a message, but, you could separate them by the entire universe. And if something happened on one end, the other one would react instantaneously across the other side. So how it works, no idea. That it works, amazing. But yeah, that's
a great way of putting it.
Know about it.
It's so true. How this works, I have no clue, but it is amazing. You're right on target. And then true quantum light, the other part of this equation, is light whose behavior cannot be described by classical electromagnetic waves and instead requires a fully quantum mechanical description, typically involving single photons, squeezed states, oh my, or entangled states. This is the kind of light that exhibits non-classical statistics and non-classical correlations that no classical wave model can reproduce. Well, sure. Look, again, though, we're talking about using standard equipment, but equipment that's been developed that it can play a game based on some very geeky quantum factors. That's what's going on here that makes this so clever. So here we go with real world results. The team measured with this device they created, they measured the distance between two buildings on the campus, the Queens Building and the Wills Memorial Building, about 155 meters apart. And the accuracy they achieved of measurement was better than 0.1 millimeter. Oh my goodness. And the measurement time, how long did it take? 0.1 seconds. What?
It's crazy.
And the laser, oh, you're going to love this, folks. How much power was needed to do this? Lower than a common laser pointer that we use in a lecture hall. Lower than a common laser pointer. They were able to use something that low power, overcome sunlight and noise factors, take ideas from some very geeky quantum stuff, put it all together, bibbidi-bobbidi-boo, come up with this measurement system that's unbelievably accurate. Wow. And the potential applications could be for autonomous vehicles, giving better sensing in bright conditions, high precision surveying and infrastructure monitoring, which is what the photo in the article and the test they did on campus is related to. Could be good for navigation and positioning systems and long-range measurements for space exploration. Wow.
Yeah, the whole ability for autonomous things to maneuver really strikes me, because, if it can measure within 0.1 millimeters, really, really tiny distances, and it can do so almost instantaneously.
Yes.
Ralph, you could just imagine that for shipping, for moving, for construction, for so on and so forth. The computer, maybe one day a computer would be able to, not just park your car, but park your boat, park your construction equipment, really just. And Ralph, I could imagine in a we were talking about Autodesk and Google before the show, so construction's on the mind. But, that's kind of the part where humans need to really be there to kind of line stuff up and really measure twice and, get things all snug up. But, hey, if computers can look at this and sense that in real time super quick, I mean, that's going to help so many industries, construction included.
Absolutely. Oh yeah, the applications for measurement are just so widespread. It's hard to wrap your head around.
Absolutely. So no, awesome story, and to be able, for them to be able to do it in real life, like not just in a laboratory setting, very, very cool. So story number 3, story number 4, and I think there was a movie called Shutter Island. I think that was the one where celebrities and high wealth individuals could essentially pay to raise a clone on this island. And then when they needed to harvest organs and other things, they would just harvest their clones that were living on this island. And it was quite a tribute movie. But hey, let's go ahead and do it in real life. Story number 4.
Yeah. Story number 4. And folks, if you're brand new to the show, most of the time, the 4th story of our set is medical technology related. And this one is so amazing. It's a story from the publication called Institute of Electrical and Electronics Engineers, better known with the geek world as IEEE. Spectrum is the outlet. And the headline here, How Your Virtual Twin Could One Day Save Your Life. Now you're going to find out it's not a whole body twin, but the heart. Oh. And so there's a great video, by the way, in the show notes. Check that out. It's really compelling. And let's get into this. The article explores a decade-long evolution and medical impact of the Living Heart Project. Now, the Living Heart Project has grown into a global ecosystem involving over 100 institutions, including researchers, device manufacturers, and regulatory authorities. So that's what this is all about. Launched in 2014 by Dassault Systèmes, the project aims to revolutionize cardiovascular care by creating high-fidelity, physics-based digital replicas of the human heart. And it gets even better. Stand by. The core technology of this virtual twin concept, unlike traditional 2D images or static 3D models, these virtual twins, digital replicas, are dynamic simulations that integrate multiple complex systems, including multi-physics modeling. The models simulate the interplay of electrical signals, the pacing of the heart, muscle contraction, the mechanics of the heart, and blood flow, the hemodynamics of the heart. All these are considered in this digital replica. And data integration, they are built using industrial-grade simulation software combined with, and here it comes, I love this part. Let me say it again. They are built using industrial-grade simulation software combined with patient-specific data captured by MRI, CT scans, and electrocardiograms. So not only are they making an incredibly realistic digital dynamic twin, but the twin part is they're making it based on your heart. I mean, in 2011, if my surgeons had had this technology, they would have been able to play around with my virtual heart before they went in and did my quintuple bypass, right? So, I mean, wow.
Yeah, to get that kind of information, again, not even just like, oh, well, you have to account for all of these situations. No, you're not even trying to train, your surgeon on everything. It is training it on Ralph, and that is
I know, isn't that
super,
it's just
super
so
crazy.
It's just so wonderful. And here comes artificial intelligence. So the next nugget here in this story, generative AI. Recent phases of the project incorporate generative AI to create thousands of virtual patients, allowing for massive computer-based clinical trials. What? Wow.
Clinical trials, but without human experimentation. That's
or animals, yeah,
or even animals. Like really, and Ralph, I'm actually, and I'm sure we'll get further into this in just a second. But there are groups that you cannot study on because of the implications. Children, pregnant women, stuff like that. I'm curious. Digitally, though, hey, maybe you could get some more treatment to some more people. Who knows?
Oh gosh, yeah. Again, think about this. What they're saying is if through MRI and CT scans and so on and so forth, they get a very accurate, I'll say, picture of, say, your heart or other organs down the road, then create incredibly accurate digital simulations that you can experiment with, that you can role play with, you can do simulated surgery procedures to get it down perfectly, or this is data that could be fed into robotic surgery equipment, right? So there's all kinds of implications, but let's get into some of the applications the article talks about for this technology. Well, medical device development, no surprise there. Engineers use the models to test pacemakers, artificial valves, and stents in a virtual environment. This provides highly detailed evidence, for regulatory bodies like the FDA, accelerating the approval process while significantly reducing the need for, in this case, animal testing, right? How about this? Precision surgery. I alluded to that a moment ago. Surgeons can create a virtual twin of a specific patient's heart to rehearse complex procedures, as we mentioned before. Now, get this. Hospitals, to your point, Ben, this is perfect. At hospitals like Boston Children's Hospital, this allows doctors to optimize surgical strategies before the patient even enters the operating room. To your point about not being able to mess around with kids or pregnant women and so forth, but you could do this before and have a very accurate plan for surgery on something like a child's heart, which is a very, very tricky and difficult procedure. And then disease prediction by adjusting tissue properties or structural variables at a touch of the button in the simulation. Researchers can simulate how heart disease progresses or how a specific patient population might respond to a new drug. Folks, this has been a terrible news week. If this doesn't leave you feeling better, optimistic, and a good example of the positive side of artificial intelligence, I rest my case. There you go.
It's really picking up on another trend that we saw, Ralph, with organoids, and I don't see how these two don't, kind of intersect. Not that you're going to replace organoids, but it's going to, blend with it. Yeah.
Absolutely. That's a great point to raise. Yes, organoids and this technology, what a great coming together.
Yeah, it's, because you can imagine if you digitally you see some response, maybe then you move on to organoids and try it in real life. And hey, Ralph, what used to take maybe even years or decades to develop something may take just months at this rate. There's a lot of hope out there for medicine in particular when it comes to science. So there you go.
Absolutely.
Ladies and gentlemen out there, you may notice that if you have been following along with the show notes, computeramerica.com, there is more to this whole thing because we're trying to keep the show a bit more condensed, 4 different stories, but Ralph finds another 4 stories in the honorable mentions, sometimes more, sometimes less, but these are stories that we just don't have time for. They're still awesome. Researchers are doing amazing work and you should go check these out, but we'll at least give you the headlines and you can come out to the website and you can find these for yourself if you want, a little bit more light reading. So Ralph, let's do the honorable mentions.
Yes, light reading. That's good. This has been a geekathon today. Okay, our first honorable mention, we're going to have 4, comes from the University of Missouri. This is really cool and a great example of a trend. A big trend is how do we get microplastics out of water? So this story from the University of Missouri, the headline is Lab-Grown Algae, or algae if you're UK, removes microplastics from water. Check that out. It's really encouraging. Our next one. Yeah.
It's so simple, Ralph. Just put it through my body and my body will trap all of the microplastics in my body and expel it. So that's good.
That's one way to do it. Okay, our next honorable mention. This is such an interesting website. I just stumbled on it a couple of months ago, and this website is very interesting. It's called Yanko, YANKO design.com. Headline, a wind-powered tumbleweed that heals the desert as it rolls. A kind of poetic headline. What it is, it's this really simplistic, clever little guy. And we've seen other technologies that say the tumbleweed's figured out something. And if you're from the East Coast and not sure what we're talking about, just Google tumbleweed. They're these bizarre plants that are sort of like a globe shape, and they eventually detach from the ground. And the way they spread their seeds is by tumbling in the wind, and it disperses seeds. So these folks, featured in the article, said, hey, we can get an inspiration to this to help reseed arid areas that need help in reseeding either natural plants or agricultural plants or whatever the case may be. So Yanko design, very, very interesting. Check that article out.
Or just watch any old Bugs Bunny, Tom and Jerry cartoons set in the Wild West, and there'll be tumbleweeds all in the cartoons. This looks like a jumble of clotheslines. It's very unique.
It's so clever, and it's like those little triangular sails embedded in this kind of geometric form. You just have to see the picture. Come to the show notes and check it out, folks. Our next one comes from fastcompany.com. Headline: these designers made a sustainable new building material from corn. Okay. 3D printing in architecture and construction is a big deal these days. You're going to see more and more and more of it. The question has been, what's the building material? Most of the time, it's kind of traditional concrete or some variations of concrete. This is talking about a printable material for buildings made out of corn.
I mean, I don't need AI. The lowest hanging of fruit, just Ralph, corncrete, right?
Corncrete. Right. Oh, I like it.
yeah, just corncrete. Concrete. Makes sense.
Yes, that's it. That is biocomposite. Okay, here we go. Our last one comes from the University of California in Irvine. Headline: research group co-led by UC Irvine develops first of its kind pump. The headline is ratchet-based device aids in seawater desalination, energy, and biomedical applications. But I think the key here is seawater desalination, which, as we all know, is a hugely important thing that's going on. Well, in the Middle East, of course, and in Africa and other places where they really need fresh water supplies. And if we can get to a practical, faster way to desalinate seawater, then this is a story that fits into that category. So check it out. That's our last honorable mention for this week.
Absolutely. And what a great slew of stories. Ladies and gentlemen, once again, computeramerica.com will have everything that you need to really find all these stories, and also all of Ralph's side notes. Really add some context in there because, we were kind of joking a couple times there, but these stories are very, very new, very researched, but very important at the same time. Just in case you're, looking at the news, looking at the headlines and saying, wow, nothing's going right. Well, there are. It's just, you got to find it. And Ralph finds it every single week. So we'll be back next Friday with more Ralph Bond. And everyone out there, have a great weekend. Do something fun. Catch a movie. And until then, thank you so much. Tune in again next time. Everyone, have a great weekend. Bye, everyone.